Welcome to the batch production setup and scaling screencast for the data movement topic of the vFabric reference architecture. In this screencast, we'll cover setting up our vPostgres staging, reporting, and job databases. We'll set up the TC Server cluster using Hyperic and set up vFabric Web Server to act as a load balancer for our cluster. And then we will run our copy orders batch job against the cluster using a single node cluster, and then we will scale the cluster horizontally by adding a second node, rerunning the job, and realizing some performance gains. So first we'll set up the vPostgres database. Look to topic 5 for instructions for installing vPostgres. We assume that you've copied the VFRA vPostgres folder under topic 5 to your Postgres server, and then we're going to run a bunch of scripts shown as the Postgres database user. So I'm currently logged on to the Postgres server. I'm in the VFRA Postgres folder that I've copied, and I'm going to go ahead, I'm in the bin directory. I'm going to first create the databases in the Postgres server. So I'll execute create batch dbs.sh. And then my next step is to create the batch tables. Go ahead and do that. So the next step is to actually load the staging data, and I'll do that by executing load batch staging data.sh. Now this will take a little bit of time, so we'll wait for this to complete. So the load is completed, and I've confirmed that by connecting to the batchdb STG or staging database and issuing a select count, and I can see that there are 500,000 orders that have been copied to the staging database. I can also see that in my reporting database I have a reporting schema and an order table as expected, and in my job database there is a set of tables under the default schema from the Spring Batch job repository schema. So now that we have our batch databases in place, we're going to look at setting up the TC Server cluster using Hyperic, assuming that TC Server and Hyperic have been installed as described in topic 5, and also that 2 TC Server instances have been created based on the Spring Trader batch template that's available in the distribution under topic 5, and they've been added to Hyperic as resources. So we'll focus on creating the TC Server batch group, adding a single node initially, or single instance. So here we are in Hyperic. We've gone to Resources, Browse. This shows us the list of compatible groups or clusters. We're going to go to the Tools menu and say New Group, and then we're going to call this group TC Server Batch Group. And then for Resources Contain, we'll select Compatible Cluster, and then TC Server Runtime 7.0. Say OK. And then from the inventory page, I say add to list. I select one of the runtime instances I had created because we're going to create a cluster with one member. Add that, say OK. So now I'm going to deploy the worker app to the instance, but first I have to build it. So to do that, I need to go to my development machine where I have Maven set up, and I have the distribution, and I'm in topic 11. I'm going to cd into VFRA batch and then issue a Maven install from here. That will go ahead and build the WAR file for the worker application. So a few minutes later, my build is successful. I'm going to cd into the VFRA batch worker folder. From here, I can see that my WAR file is available under the target folder. That's the file that I want to deploy using Hyperic. So I'm back in Hyperic, ready to deploy the app. I can now go to Views, Application Management. So under Deploy an Application, you can see that I've chosen the WAR file that we just built. And now I need to set the context path to VFRA batch-worker and go ahead and upload and deploy the file. Now my deployment just finished successfully. I can see here that the status is successful, that it was deployed to the one member of the group, and that it's listed here as one of the deployed applications. So to validate the deployment, I'm going to run a ping application. So I'm going to go to the context root of the application I just configured in the deployment step and go to /ping and I should see a simple message that says ready for work. Now we're going to set up the vFabric web server that will act as a load balancer for the cluster. As prerequisites, we've installed the web server as described in topic 5, and as well we have issued the new server PL command to create the VFRA batch web server. Simplest way to get through that is to skip the SSL configuration. So now I'm on the VM where I have installed the vFabric web server, and I'm in the root directory for the install, and I've already used the new server.pl command to create a VFRA batch web server. So if I change into that directory and go into the conf directory, and I've already made some edits to the httpd.conf file. I'll just quickly take a look at that. This is by default enabled. There's a load module for the proxy balancer module. If I go to the end of the file, I've added a single balancer member, the TCS-01 VM, to the proxy configuration. So that means that it's going to essentially just forward requests to that one TC server at this point. So now I'll cd to the bin directory and issue the restart command so that my changes take effect. And one more test, I'll actually use the URL of my web server and try the ping command for that. And it works, so I know that it's successfully forwarding requests to the TC server instance. So I have my cluster configured with a single node, and I'm ready to run my copy orders job against the cluster. I have configured my database properties for my command line master script as described in the install docs, and I'm ready to run the copy orders job. So in this case, we'll be using a partition size of 4 with a single node in the cluster. That means all 4 requests will be sent to the single node by the load balancer, and they'll be executing in parallel because we're using a task executor thread pool in our job configuration. So I'm back on my development machine where I had built the worker app War, and I have Maven installed, and I'm going to cd into the VFRA batch core folder, and from there I'm going to execute my shell that will kick off the job and the master process. So my job is running. I can see that the partition size is 4, so 4 requests sent by the master process via the load balancer endpoint. And I also can see that I have a running count of 4, which means there are 4 active partitions or step executions. And at this point, none of them have completed, so successful count is 0. And that's based on information written by the worker threads to the job repository that's being polled or read by the poller within the master process. And now I can see that the job has completed. The running count has gone down to 0. We've had 4 successful executions, and that makes sense because we have 4 partitions and therefore 4 step executions. So now I'm going to look at the results of that job using the admin application that was discussed in the reporting and admin demo. I'm running the admin app in STS, but I've updated the database settings to point to my production Postgres database. So I'm able to navigate to the job and execution. I can see that the job took 9 minutes and 49 seconds. I can drill down into the details of the job and see exactly how many partitions were executed and the amount of time associated with each partition. So now we're ready to scale our cluster horizontally by adding an additional node to the cluster. So we'll follow the same steps of adding an additional TC server instance to our Hyperic resource group, and then adding that instance to our web server configuration, and then rerunning our copies order job. But we'll increase the partition size to 8 so that on our 2 nodes there will be 4 partitions or parallel threads executing per node. So now I'm going to add a new member to the TC server batch group. I can go to inventory while I'm in the batch group context in Hyperic, and I can say add to list, select a runtime which already has been created, press OK. Now it shows under inventory that I have both members added to the group. So the next step is to deploy the application to my new member. So I'm going to actually select it specifically, and from this context, click Views, Application Management, and then deploy my app to the specific server. My application has deployed successfully. If I go back to the TC Server batch group context and look under Views, Application Management, I can see that the batch worker app is now deployed to 2 out of the 2 servers. Now that I have a new TC Server member, I'm adding it to the web server cluster configuration. So here you can see under my proxy element, I have a new balancer member pointing to TCS02. And as before, once I save this file, I'll go ahead and restart the server. So now that the load balancer is configured, I can ping my new server. I know that it's available. I can also ping the load balancer endpoint, and I know that it's working. I can do it multiple times, and I can check the TC Server logs to confirm that it's distributing requests to both nodes. So my final step is to run the master script, but before that, I need to edit the partition size properties and do a Maven install. So I'm in the batch core project, and I'm going to edit the VFRA-batch properties file and increase the batch partition size parameter to 8. And then I'm going to do a Maven install. It'll copy the change property file to the target directory, and then run my copy orders job shell again and compare the performance as soon as this is done. I'm back in the batch admin, and just wanted to note that you can also check the status of a job through the admin UI. So I can see here that I have a job started. There's no exit code known at this point. I can go look at the partitions. I can see there are 8 child partitions in various states, and I'm able to update this and get a count of written records as well. So my job completed, and I can see that it took 7 minutes and 45 seconds, and I had 8 partitions, and they divided the records evenly among them. Now if I compare this to my previous job, so the first run was 9 minutes and 49 seconds. That was with 1 cluster member, partition size of 4. My most recent job executed in 7 minutes and 53 seconds with 2 cluster members and a partition size of 8, so that would be 4 per member. So that's definitely an improvement. However, the best time I got was for a partition size of 4 distributed across 2 cluster members. So that's for both of these timings having to do with 6 minutes and 37 seconds and 6 minutes and 57 seconds. So if we look at one of them, we can see that there are 4 partitions, so there was some level of contention involved by having more than 2 partitions per node. That outweighed the benefits of having more concurrent threads processing partitions at once. So that concludes the production setup and scaling screencast. Thanks for watching.